Welcome to another 12 News Weather School lesson. Today's lesson is going to be what I feel is one of the most valuable tools we have as meteorologists, and that is Doppler radar. We're going to be getting into how they operate, how we use them, and why they are so important to us as meteorologists and as a way to protect the general public when we talk about severe weather, whether it be thunderstorms, tornadoes, big winter storms. A very, very valuable tool. And there's a look at one of them right there. You'll see that tower, and on top of that tower, what looks more or less like a giant golf ball. That is the radome, and that protects the radar that's inside it. Now, as that radar is working, it's actually spinning. As it's spinning, it is scanning the atmosphere. And as it completes one scan, it then tips a little higher, looking higher into the atmosphere. And it continues to do that until it completes all of those scans into a volume scan. And then that data is then fed to a display, whether it be a display at the National Weather Service or a display at a television station. But they are constantly spinning like that, constantly scanning the atmosphere. And again, they are very valuable tools, especially in the time of severe weather. There's also a mobile version of a Doppler radar. This one right here, again, you can see it on a flatbed truck, heavy duty truck to pull that around very heavy objects. This one is operated between NOAA, the National Oceanic and Atmospheric Administration, as well as the University of Oklahoma. You can see the logos there on the radar itself. That's what it looks like inside that radome, inside that giant golf ball looking thing. That's what it looks like. So that is spinning, constantly spinning and scanning the atmosphere. And you can see how it tips back, starts to look a little higher and higher into the atmosphere. These are used most commonly for severe weather research. They will drive these radars into an area where they're expecting severe weather, and they'll use it as a mobile radar. They can scan that storm and they can gather lots and lots of data, and they can be in very close proximity to the thunderstorm itself, which is very valuable. The closer the radar is to the object of interest, the higher resolution, the better the picture is going to look. Now here's a look at the map of the entire United States. It includes Guam and Puerto Rico, and you can see these are the individual National Weather Service Doppler radar sites, and they cover all 50 states. And now we'll take a look at how Doppler radar actually works. So there's your radar, and then to the right we have a raindrop. Now that radar beam leaves at a particular speed and with a particular frequency. And as it hits a raindrop or a snowflake, it is then scattered, and some of that pulse will bounce back to the radar. The radar will then determine the location from the radar. How far is that object from the radar? It will also determine the intensity. So as that raindrop is moving towards or away from the radar, it will come at it with a different frequency. That tells the radar, is it moving towards it or away from it? Also, how much energy is coming back to the radar. That will tell the radar, am I looking at a light shower or am I looking at a heavy downpour? And that is what we show you on television when we watch thunderstorms or showers or snowstorms moving through the area. That's the information that the radar is getting, but it puts it out in a display, color codes it, yellows and oranges, greens, reds, purples, things like that, to basically show you, again, the intensity of whatever it's looking at. So here's another way to look at that radar beam. As the radar beam is leaving the radar itself, it's a very, very small radar beam, but as it is moving away from the radar, it starts to grow. It actually gets bigger and bigger and bigger, and because of the curve of the earth, it actually looks as though it's lifting off the surface of the earth. It's actually going out in a straight line, but because we live on basically a ball, it is curving away from the earth's surface. And that is what happens to the radar beam as it moves further and further away from the radar itself. So when we have thunderstorms very close to the radar, hence the one to the left on this graphic, we get a really good picture of what's going on inside that thunderstorm. It's a high resolution picture, just like your television screen or your computer screen. High resolution, high quality picture. But as that beam is going further and further away from the radar, that beam gets a little bit bigger and it starts to paint with a bigger paintbrush, and we start to lose that great detail, that high resolution detail starts to drop off. So the further away something is from the radar, the less resolution we get with it, the less detail we find with it. But as I mentioned earlier, it also scans in the vertical. So as that radar is spinning, it starts to tip back a little bit higher and higher, looking higher into the sky, and we call that a volume scan. It takes all the scans and basically makes a big composite of it. So we can look high in the sky and see the tops of the thunderstorms as well as the bottom of the thunderstorm. And some of the most recent advancements in Doppler radar is actually using a vertical and a horizontally orientated radar beam. And this gives us kind of an XY look at objects in the atmosphere, meaning we can now look at the shape and the size of those objects. The radar is getting smarter. The radar can tell us, are we looking at small raindrops? Are we looking at large raindrops? Are we maybe looking at hailstones? Or are we looking at something that isn't spherical, quite possibly some debris? So around tornadoes, we get what we call a debris ball. So as that tornado is moving through and it's tearing things apart and basically spinning that stuff up into the atmosphere with a good high resolution image, that radar beam can tell us, hey, we're not looking at spherical raindrops anymore. We're looking at debris. We're looking at maybe 2x4s or pieces of siding or pieces of fencing that's actually being tossed into the air. And that radar nowadays can tell us we have this debris around this circulation, which we believe to be a tornado, which we're actually going to talk about here in just a moment. But in addition to seeing the objects in the atmosphere, I also mentioned that we can tell if they're moving towards or away from the radar. And we use a color coding to determine the speed at which it's moving and the direction at which it's moving. So in this graphic here, the radar is in the middle of the entire scene, and we have everything moving from south to north or bottom to top on the screen here. As that object, whether it be a raindrop or a hailstone or whatever it might be picked up on radar, as it's moving towards the radar, they color code it with the color green. The faster it's moving, the brighter the color green. Now, as that object or that phenomena is moving away from the radar, we color code it red. And the faster it's moving, determined by the Doppler radar, the brighter the red. So this becomes very important to know the orientation or direction things are moving when we talk about finding those circulations within the thunderstorm, because those very tight, organized circulations can turn out to be tornadoes. So here we are looking at the reflectivity or the intensity of that rain on the left, and then on the right we're looking at the velocities, which way things are moving and how fast are they moving. Now in this case we have a hook echo, and we hear the term hook echo, we think tornadoes, we think severe weather, we think dangerous thunderstorms. So on the left you see the hook echo. You can see how that red hooks around itself, looks like a hook, hence the name hook echo, and that black circle right there, that is also indicating where our hook echo is and where we think the rotation might be. Now as you look to the right, those are the velocities. And remember, reds are moving away from the radar, greens are moving towards the radar, and right where that yellow circle is, you see that bright green on the south end of it, and you see a bright red on the north end of it, all encircled with that yellow arrow. Right there, when you have a very tight circulation, you're going to find a very fast outbound velocity next to a very fast inbound velocity. And that's the radar picking up that tight circulation. And in this case, what we're looking at is we're looking at what the radar believes to be a tornado or tornado vortex signature. Vortex meaning spin. So what it looks like on radar when you look at the velocities, a tornado looks like a bright red area next to a bright green area. We call it a couplet, and that's that circulation. And this is how a Doppler radar would alert you that there quite possibly is a tornado. And finally, as I mentioned before, there are other things, biological things, that do get picked up from radar, and that's why the meteorologist needs to be very aware of what they're looking at. And you look at a lot of the behavior. How is something moving through your radar scope? Now, to the left, those are non-biological features on a radar. And the first one you see is clutter or ground clutter. Most often you may pick up airplanes, and nowadays more often you're going to pick up wind turbines. Now the wind turbines will appear as kind of like thunderstorms, but they stay where they are. They remain stationary. And so when you see that, it looks like there's just a constant thunderstorm in one spot. That's a clue that you're looking at something that is not weather related. The other thing is precipitation. That's what we always show you on air. The yellows, the greens, the oranges, the reds, the purples, all those colors, that's the precipitation. But sometimes when you think you might be looking at a light shower, it could be something of the biological sense. And what we have here in front of us, these are 3 examples: birds, insects, and even bats. So when birds start to migrate, when insects start to basically begin to appear, when you go from winter to spring and everything's starting to blossom and grow and whatnot, and those insects are out and about, they even get picked up on radar. Sometimes bats. Many times bats will leave their homes for the night to start hunting, and you'll start to see what looks like just a blossoming light shower appear on radar, and it's the bats just leaving for the evening. Well, that's today's discussion about Doppler radar. Thank you so much for joining me for the 12 News Weather School. I hope you found all this to be enlightening and entertaining, as well as giving you a little bit better appreciation for that tool that we use day in and day out, especially for severe weather, Doppler radar.